Hello and welcome back to how to make an operating system with Rust and aarch64. It's been a while and yeah, a few things have happened while I didn't put up any videos, but now I'm back. The first thing that I want to talk about is I started making a GitHub repository for everything. I renamed the operating system to ADTOS and added license and socials. And you can find the operating system on, let's see here, on this page, Tech ADTOS. It's licensed under the BSD 2 clause license, so you can just use any code in this repository provided you also include the copyright notice. As for what I want to do this episode, I want to clean up a few things. The first thing that I want to clean up would be in boot.s. First thing that I've noticed is I have a typo. Initialize. And I want to disable the following. On aarch64, we have a register called the one second system control register. So let's see, we are setting up the stack here. So let's do this after here. So what I want to do is disable stack alignment requirement. What that means is our stack does not have to be 16 byte aligned, so we don't always have to push two variables. How we do that is we use the system register called EL1. This is the system control register in the exception level 1. And here we want to clear the following bit. Let me pull up the documentation real quick. Stack. That would be the SP. SA, here we have it. We want to clear this register. Okay. Let's put everything to the wrong. It would be one of these. We want to set the stack alignment bit, and when it's set to 1, the load or store instruction executed in EL1 uses SPSD base address, and if the SP is not aligned to a 16-byte binary, so 2 variables, then an alignment fault is generated. I do not want this right now, so I will just disable that. To disable that, what I'm going to do is we are going to read the system control register. So to do that is mrs into we're using x9 here, we're using x7, so let's keep using x7. What I want to do is I want to do a bit clear into x7 of x7 and clear the third bit, 1 shifted by 3 bits. And that we store back to the EL1 register, and that should disable the alignment. Check. Okay, that worked. Then the next thing that I want to do is I would also like to clear the BSS section. So, well, if we recall real quick, in our linker script, we have a BSS section. This BSS section needs to be cleared to 0 if there are any variables in there. So what we're gonna do in boot.s, I think I would also write a function called clear BSS. Okay, so in this function, what we want to do is we want to grab the BSS segment. So let's see. We want to grab the BSS segment, which we would do like this in x0. We want BSS start. In x1, I want BSS end. And let's define these real quick. So here we want to define BSS start equal to dot, and BSS end is also equal to dot after the BSS. What I also want to do is I want to define if we're here real quick. If we turn on the MMU, we have something called a granule size, which is basically the unit, the amount of bytes that you can allocate. So the minimum amount of bytes you can allocate. What I'm gonna use is I'm gonna use 16K. So what we're gonna do is I'm gonna say page size is equal to yeah, let's just use 1024 and then 64. And that should be 64K. Now we're using, oh no, I wanted 16K pages. 16K pages. Okay. And then what we can do after here, we can put an align page size. And that we would do everywhere. Page size. And for good measure, I think I will also put one here. Dot equals. No, how do you do this again? Give me 1 second. I would check real quick. Okay, yes, I would set or dot equal to align to the page size. Okay, that would be it. So what did we do? We got two labels, BSS start and BSS end, just as we did for our relocations. We aligned everything to the page size, which makes our binary bigger, but it allows us to actually allocate these in different pages. That looks good to me. Then back to boot.s. What I want to do is I want clear or the BSS section. To clear the BSS section, Let me think. Yes. So to clear the BSS section, we got these two start and end positions. We want to set everything to 0. For that, we can use a store pair instruction. And then store to x0 to what's in so the 0 register to what's in what's at x0, and we can increment the whole thing. So it's the same as here, as up here where we load 16. So we store a pair, so we need another x0 here to here, and we increment by 16, and we compare x0 to x1 and branch not equal 1 backwards. And after we're done, we return. And this should technically work if I'm not mistaken. Okay. So then, before I do anything, let me see. Since we are starting multiprocessor, we want to clear BSS only once. So what I want to do is I would say let's keep this with star. Let me think. I want a label here, and this label will be, let's see, let's call it common start for now. And only in start, we're going to branch with link clear BSS. After that, we're gonna fall through to there. Yes. And let's maybe use different registers. Let's do x7 and x8 for now. So just to iterate what we're doing, we're getting both pointers. We store 2 zeros to the location, increment by 16 bytes. Then we compare if they are equal. If they are not equal, we jump back to storing and incrementing. Otherwise, we return. Okay. Good there. Let's build this and see if it runs still. It does not run anymore. So let's debug this real quick. Run this. Then we use Rust GDB with target, and I would use ADTOS. We target remote 1, 2, 3, 4. Add symbol file. And we want to add the symbol file Give me 1 second. We want to add it here. Oops. Did we add the right thing? Oh, of course. This. And now we do layout ASM, layout regs. Let's zoom into this and see what it is doing. It is actually storing the things. Ah, but we're cruising right past it. Because we're incrementing 16 by, or because there is, wait, yeah, we've passed it. So, okay. Let's go to linker. We got the start, which is a lower address, and this is a higher address. Here, BSS start and BSS end by adding 16. Then let's actually look. They are the same at start. So I will just no. Hold up. I need to do at least one iteration, I think. No, I don't. We're branching if equal to this. And then I want to put or store here. Is this a thing? Yes, it is. So it's waiting for me to attach. Target, remote 1, 2, 3, 4, layout ASM, layout rex, zoom in. We add, we compare. And if it's greater than this, oh, yeah. This is not gonna work. Because what did we just do? We broke it. So the one forward, then here we want, let's call this 1, let's call this 2, this 2, and here we want to do the same, compare x7 to x8. I wonder if this working. branch less than x7, x8. Branch less than, and then 1 backwards. Okay. Let's see again. The same. Also, since it can never be let's do this. Give me 1 second. Yes. So here I wanna branch if it's greater or equal. And here less than equal. Okay. And I also think we should not use signed. So greater than equal would become higher or same. So HS, and lower than equal would be lower or same. Let's see if this will compile. Yes. And run this. Debug. Okay. Now they are the same. X7, X8 are the same. If it's carry set, we return. Nice, it works. Good. This means we're clearing BSS. So to test the clear, in main, I guess, I will just put a static. So static test is an array of u8, and it is how big? Let's say 2048. I think I did this the wrong way around. Okay, let's see if I did it right. We didn't do it right. I did it. 2048. And then I always get this confused, the syntax. There we go. Now we should be able to run this and see it clear the BSS. Here we want to target remote 234. We are going here. Our two things are still the same. Why are they still the same? Probably because it's not used anywhere. Let's just do something stupid, like, I don't know. Test at 10 plus x41. I'm not sure if this will work. This will work. We run this. They're still the same. That is odd. Maybe I'm not smart enough to know how the BSS works. So, yeah. Is this right? Anyway, what I can do to test it is I can just move. This should be aligned to the page size. Dot plus equals 1 just for test. Or let's actually do it plus 4. And then we should have a full page. Clean it. Then we should have a full page that is allocated. Oops. Yes. It's different now. And we are actually storing stuff. Good. So what I'm gonna do is put a breakpoint at 48,000,9C. Oops. Let's do this. Paste and oh, we can't do this. So star. Paste. Okay. This was the wrong one. I wanted this address, of course. B star this. And then how do you clear breakpoints again? Help. Yes, I found it. Delete breakpoints. Yes. Then we break here. And I didn't do it right again. There we go. Okay, and we continue. It fell through after doing its thing. And now we go as normal. And everything is broken, as it seems. Oh yeah, but every core goes through it, which should not be the case. So source boot. Now we clear BSS, and then we also in main RS we say instead of start we want common start. Common start. Okay. And now if we go through it and set a breakpoint here, we should only see it be hit, yes, one time. And my GDB crashed, but that's fine. Okay, that all seems to work. So what did we change? So we changed debugging, we cleared BSS, we disabled the stack alignment, aligned everything in our linker script. We changed the start function. I didn't get as far as I wanted to, but I think this was necessary. Since now we can actually use stuff in the BSS. So what I'm gonna do, what did I just do? What I'm gonna do now is in a linker script, I will just take this away again. And now if we put stuff into the BSS section, it will be fine. Okay. Also take away our test. Okay, we already did. Yeah. What I also kind of want to do is I want to make this stack a little bit bigger. Like instead of 498, I want 1024 to, let's give it 32 kilobytes. Sounds good for now. 32 kilobytes, and also take away these guys. And it looks like it still works, so this is fine. Okay. Good. Okay, so that's that for this episode. We now are clearing the BSS, aligning everything. In the next episode, I'm gonna build the memory map a little bit more, so that I can plan out where everything goes. See you in the next episode. Thank you for watching.